Hey viewers, welcome back to the channel. Hope you are doing extremely well. So today we are going to discuss another question, that is inverse of a number left to right. So in this question we are provided with a number. Let me write a number. It is 5, 2, 6, 1, 3 and 4. Okay. So what we need to do in this question is that we need to work on that question and find the inverse of that number. So before moving further, there are some properties associated with number which is explained in the question. The first property of this question of this number is that it will contain only the continuous digit. That means a number like this 7 6 1 3 4 will never be encountered, and it is a wrong number. For this question, okay. Now the second property associated with this number is that it will contain its digit value will range between 0 to 9. Okay, so let's try to understand what is the inverse of a digit. The inverse of a digit is nothing but the interchange of the value between the face value and the index value. So let's try to understand. What if I will give these digits some index, like it will be 1 2 3 4 5 6. Okay, so as I have given each digit some index, so what will be the our output according to the question is that what will be our output according to the question is that we need to swap the face value and the index value. Means, as let me write the index 1 2 3 4 5 6. As this 5 is coming here at the index 1, so in my output the 1 will come at index 5. Okay, so you can see here we interchange this face value with this index value. Similarly here 2 is coming at index 2, so here also 2 will come at index 2. Now moving to the 6, the 6 is coming as index 3. Okay, now we interchange it. The 3 will come at the index 6. 3 will come at index 6. Okay, so similarly 4 will come at index 1, 5 will come at index 3, and 6 will come at index 4. Okay, so I hope you got the question. Here we need to find the inverse of this number, and inverse of this number is nothing but the interchange of the face value and the index value. So pause this video right now and try to solve it by yourself, and then we discuss its solution approach. So I hope you had tried it by yourself. So let's try to understand it. Okay, we know that in this question we are provided the number 5 2 6 1 3 and 4, and each number is associated with some index like 1 2 3 4 5 6, and we need to interchange this interchange its digit with its index value. So the first thing about this question is, what if I will say the maximum digit of the provided number will be nothing but the size of this number? You might be thinking that how the maximum digit will be nothing but the size. I can say it easily because I know that the digits are continuous. Like if I am provided with 1 2 3 and 4, then the maximum digit on this question will be nothing but the 4 itself, just because the digits are continuous. Okay, so similarly here the maximum digit will be nothing but the size, and let me store it somewhere here. Okay, so we know according to our question, as it was mentioned, that we need to swap this value, this face value, with this index value. So now we are going to do this question is that we are going to find the accurate position of this index value using this face value. Means 6, we can find the position of 6 in the correct output using this 4. Similarly we will find the correct position of this 5 using this 3. Similarly we will find the correct position in our output using this value 1, face value 1. So how do we find it? We will do nothing, just use the old concept of the modulo and the division, okay, and the basic math. Let's try to understand how. So at first we know that my maximum digit is 6. Okay, and I will start finding the position for the 6 only at first, because I'm start iterating from the backward. Okay, so at first as we are finding for the accurate position of the 6, so we need to take the help of this 4. Let me extract this 4 from this number. So we know that how can we extract this number from, how can we extract a digit from a number? We already know that. Okay, so what will be the accurate position? Okay, let me write the accurate output somewhere here. Okay, output will be nothing but 4 to 5 6 1 3. It's position 1 2 3 4, 5 and 6. Okay, now the 6 will come at position something x, which I will easily find it by 4 with the help of 4. How? What if I'll say the position of 6 will be nothing but somewhere power of 10, and this power of 10 will be nothing but the total number of digit minus this face value. How? At first let me write what I've said, and then we figure out that how my statement helped me to calculate the position. Okay, so what I said, the position of this, like 6 multiplied by, okay, right now let it be 6 mat dot power of 10, something power of 10. And what was that something? That something was nothing but total digit minus this face value. Currently it is 4. Okay, so let's try to figure out that what its value. It is 6 multiplied by, we know total digit is 6. Okay, total digit is 6, so 6 minus 4 is 2, and 10 to the power 2, that is 100. So its value is 600. So here you can see that even in our correct output, the 6 is placed at the position 100th. I think we have accurately find out the correct position for the 6, that is 600. Similarly, what we'll do, we'll find, let me take it to somewhere here. Okay, similarly we know that how will we find out, using this formula we will find out the correct position for this 3. Okay, so this time, I ignore this. We are finding the position for this 5, means we are finding the accurate position of this 5. So we need to extract this 3, this face value, so that we will easily find out its position of 5. So this time, as we are finding the here, so as we are finding the position of 5, so 5 multiplied by mass dot power of 10 multiplied 10 power total digit, that is 6, minus here the face value is 3. Okay, so let me change this 4 with this 3, with this 3. Okay, so here 5 multiplied by mass dot power of 10 10 to the power 6 minus 3, that is 3. So here I get 5 into 1000, that is nothing but the 5000. But when I look at my correct output, here I can see that my 5 is placed at the 1000 position. That is accurate. Oh, absolutely accurate. Okay, so let me take this value to here. Okay, so according to so as you can see, we can easily find out, we will perform the same operation for the 1 to find the position for exact position of 4. Similarly, we do the same for the 6 to find the exact position of 3. Similarly, we do it 2 to find the exact position of 2, and at last we do it for 5, do it for 1 to find the correct position, do it with 5 to find the correct position of 1. Okay, along with this, one more thing we are going to do is that we are going to add these numbers which we calculate, and at last we get this number. So let's try to code it on the compiler. Okay, so this is our pap coding portal, and at first we need to take the number. For this we create a scanner. Okay, so let me get the number. Okay, so the first thing we are going to do is to find the maximum digit, and maximum digit will be nothing but the total number of digit. So total digit, let me take it with, so while, okay, let me take a temporary variable and update it with n while temp is greater than 0. What I'm going to do is that temp divided by temp divided by 10, and update my total digit plus plus. Okay, so here you can see I have correctly find out the total digits, or I can say I have correctly find out the maximum digit within the provided numbers. within the provided number. Now what I'm going to do is I'm going to find the accurate position of each index using its face value. So int I equals to 0. This I will be nothing my accurate output. Okay, so let me write it as answer. Okay, so let me at first we are going, as we are going to iterate the digit from the backward position. So that means at first we find the accurate position for this for the sixth index. For this question it was 6. Okay, so it was with nothing but total digit, total digit, yeah. So we iterate till n is greater than 0. Now we at first find the digit, and digit will be nothing but n modulus 10. This is the face value for that index. Okay, now we need to shorten that number. Okay, we do it by dividing it with 10. Now we need to find the accurate position. Okay, whether it is placed at 100 position, 100 place, 1's place, 10's place. Okay, we'll do it, or we'll do it by p multiply by mat.pow 10 comma total digit minus digit. Okay, we know that total digit minus digit will give me the accurate position of the accurate position for that particular index. Okay, and after finding the accurate position for that index, I am going to add it in my answer. That is answer plus equals to this, and after finding the position for each index, I need to decrement my index value, just because now after finding the position of the sixth index, I using its face value, I need to find the index for the fifth index, position for the fifth index using its face value. So I'll write here p minus minus, and here we get the output. Let me print it. System.out.println nothing but answer. Let's try to run it. So here our answer get accepted. Let's try to submit it. So here it is accepted. I hope you get the concept. If you like this video, don't forget to subscribe our YouTube channel, hit the like button and share it with your friends. Till then, stay safe, stay healthy.